All right, new unit, guys. So I would tell you that what we're going to do in section 4 right now is probably the most important thing we do in all of Algebra 2. So this unit is all about factoring, and so we're going to learn all of these different methods for factoring. So just to kind of get your mindset right, if you see this, we've done this, I know you know how to do this, this is distribution. So what we're doing when we're distributing is we are taking this outside term and we're distributing it inside the parentheses. Okay, so we take it to the first term and we have a 6x. We take it to the second term and we would say plus 2. All right, this is not new. You're good at it. We've been doing it all year. And so what we're doing when we're factoring is we are doing exactly the opposite of this. So this is distribution. Now we're going to think backwards. So what happens is we see our two terms, which is like this. This is our two terms after we've distributed. And we have to think, okay, what is the biggest number or variable, so the common factor that I can pull out of both of these? So you see in this first one, it's a 3. So if I pull a 3 out of this first term, what's left? Well, we have an x that's left. And so if we pull a 3 out of the 12, what's left? It's a 4. Now I can check this by distribution. So 3 times x is 3x, and 3 times 4 is 12. Okay, let's do another one. So I have this, and this tells me already that I'm going to pull out a 7. So if I pull out a 7, what's left is an x. Now this is wrong. This should be a subtraction. And then if I pull a 7 out of the 21, I have 3. So I'm going to go in here and I'm going to check it, and I say 7x minus 21. That's how I knew that sign was wrong, because I have to have a negative 21. All right, so this time I tell you what's on the inside, and so we want to find the biggest factor. Well, I'm just going to work backwards. If I have a 2x, what do I have to multiply this by to get 10? I have to multiply it by 5. Now I have to check this. If I have 5 times 11, do I get 55? And I do. Okay, same thing here. 3 times what is going to give me a 9? Well, 3 times 3. 5 times 3 gives me a 15. So let's try this one when you don't have anything given to you. So I have a 4x and I have a 20. So what is the biggest number that goes into both of these? And it's going to be a 4. So 4 divided by 4 leaves just this x. And this is what I'm doing when technically I'm dividing this by 4, which tells me I have an x left, and if I divide this by 4, this tells me that I have a minus 5. Okay, now when we look at this one, as these numbers get bigger, it gets a little more tricky to find the common factor. So I know I can take a 2 out of both of these, but what happens, let's do that for a minute. If I take a 2 out of both of these, I would have a 6x that's left, and I would have a 9 that's left. Now, this is not okay. And the reason for this is because I can take out another greatest common factor, GCF, greatest common factor. This is divisible by 3, and this is divisible by 3. So what I already have this 2 out, and now I'm going to pull out a 3. So if I divide this by 3, I'm left with 2x. And if I divide this by 3, I'm left with a minus 3. So this value becomes a 6. So 6, 2x minus 3. Now, if I distribute this back in, oh, sorry, this should be plus. This sign was wrong here too. This should be addition. So if I go back and check this, I would have 6 times 2, which is 12x, and 6 times 3, which is 18. Now, if I would have just, in the beginning, if I would have seen that what I needed here was a 6 instead of a 12, if I would have divided this by 6 and divided this by 6, I would have gotten to my answer. So the key on this is if you get to your factored form, you have to make sure you have the lowest possible factors. If you can pull something else out, like I could up here in the blue, then I need to pull it out again, okay? So when we look at this number that's on the outside of the parentheses is called our common factor. And what you'll hear me say even more than common factor is greatest common factor. It's the biggest number that comes out of both of those. So I'm going to actually add that over here, greatest common factor, and you'll see me abbreviate this as GCF, greatest common factor. Okay, so go ahead and pause the video and do 1 through 4 on your own, and then I'll come back and talk about it. Okay, so if I look at this, this first one, what you see right away is an 8. So I pulled an 8 out. This is the one that gets pulled out the most often, but what you see is that you still have a 2 and a 4 on the inside. So I have to pull out a bigger number. 8's not big enough, so I pull out a 16, and when I check it, I have 16x minus 32. Over here, I'm going to pull out a 2. That's the biggest number that I have. 4 and 5 cannot reduce anymore. So if I pull out a 2, I go back and check it. I have 8x, and then I have 10y. Now this one, it has 3 terms, but it doesn't matter that it has 3 terms. It's okay that we have 3 terms. So if I distribute this back in, I would have 10x squared plus 15x minus 20. So I would tell you every time you pull out a GCF, go back through and distribute that back in to check it. And then the last one here, I pull out a 10, the greatest common factor, and I would check this as 30x squared minus 50 minus 10. Okay, what we're going to do now is we're going to distribute with variables. And so we've done this before too. So I have this variable x, and when I multiply this in here, this is not 4x, this is 3x squared. So I have an x times an x, which is 3x squared. Okay, so I'm going to write this right here. X times x equals x squared. Common mistake right here. Now, if I was adding this, and I had x plus x, this gives me 2x. So make sure you know the difference between these two. So I distribute here, and then I distribute to the second one, so plus 8x. Okay, so with this one, I have 15, so I look at just the numbers first, and then I have x times x, which is x squared. I go to the second term, plus 5x. Now, this looks a little bit different because this first term's x squared, but remember we did exponent rules in the beginning, and so because I'm multiplying, I'm going to add the exponents, so this becomes x cubed minus 5x squared. All right, let me go down here and do number 5. So with number 5, I have 2 variables on the outside. I have an x and I have a y. So when I distribute to this first term, I look at just the numbers, so I would have 6. I have an x times an x, so this becomes x squared, but I still have a y, so I have to include the y. When I go to the last term out here, I have 2 times 5, which is 10. I have no variables, so I just have xy. Okay, pause the video and do 4 and 6. Okay, here are the two when I distribute it through, and then here's number 6. So based on what we see up here, we can see that our common factor, so these are all my common factors that were pulled out of the outside. It can be a number, it can be a variable, or it can be both. So up here I was pulling out numbers, here I have a variable, here I have a variable, and actually I have 2 variables and a number. Okay, so know when you're looking for your GCF, it can be more than just a number. Okay, so here, factor each of the following by looking for the greatest common factor. So I'm looking for my GCF here. So first thing I'm always going to do is I'm going to look at the numbers. Well, there's nothing that I can pull out of a 4 and a 9. So this is even, this is odd, there's nothing that comes out of that, but I see I have an x in both terms. So I'm going to pull out the x. If I divide this by an x, or I pull out an x, what's left is 4. And then what's left here is 9. Now, we see that these are just 2 numbers that are inside the parentheses. So this is the same as 13x, right? What's asking us to do is factor. This is factored form. This is the solution to this, right? I could have done that clear up here. 4 plus 9 is 13x. If I look at the second one, this x squared, this is telling me I have 2 x's. So I don't have a number, so the only thing I can pull out of both of these is 1x. This has 2, but this only has 1. So I pull out 1x. What's left in my first term is 1x, What's left over here is a minus 7. Now when I look at number 3, the first thing I'm going to do is look at the coefficient, and I have a 2, and I also have an 8. So I'm going to pull out a 2. I have x's in both terms, so I'm also going to pull out an x. So this is an example of when I'm going to pull out a number and a variable. And what I have left is an x minus 4. Now this one's a little more tricky, so I'm going to go back and check it. So 2x times x is 2x squared, which is what I have. And then 2x times minus 4 is negative 8x, which is what I have. Okay? Let me do one more, and then actually, let me go ahead and do number 5, and then we'll have you do 4 and 6. So I look at these 3 numbers, 9, 12, and 6. Well, 6 and 12, I could have pulled out a 6, but I can't pull a 6 out of the 9. So it looks like the biggest coefficient that I can pull out is a 3. I have an x, I have an x, I have an x. So I'm going to pull out 1x. I can't pull out more than 1 because I only have 1 in this term and 1 in this term. And then I have a y, and I have a y, and I have 2 y's. But I can only pull out 1 y because I don't have 2 in this first term. So I'm going to pull out this y. So now I'm going to go back and see what's left. So 3 times what gives me 9? 3. This says I have 2 x's, but I only pulled out 1, so I need 1 more x. This says 1y, and I pulled out 1y. So I'm done. I won't put anything here for y. So now I'll go to the second term. So I had a 12 and I pulled out a 3. So 12 divided by 3 means I have 4 left, or 3 times 4 is 12. This is 1x, I pulled out 1x. This is 1y, I pulled out 1y. Now I go to the last term. 3 times what is 6? 3 times 2 is 6. I needed 1x, I pulled out 1x. I need 2 y's, but I only pulled out 1. So I'm going to add a y here. Okay, and then again, as always, I would tell you to go back and distribute and check. So go ahead and pause the video and do 4 and 6. Okay, 4 and 6 both have a very unique feature here. So when we factor out, they all can pull out a 5, and they can all pull out an x. So that's my greatest common factor, is 5x. So when I look at what's left, I have x squared, and I have a negative 2x, and then this, which always gets forgotten, I have this minus 1. Now, a lot of times people are like, oh, okay, I already pulled it out, so it goes away. Well, if it goes away and I try to distribute back in here, then I wouldn't get this last term. So we have to have this placeholder of a negative 1. And this is another reason why it's really good to go back and check. So if I pull this in, I get 5x cubed, right? And then I have minus 10x squared, and then this last term gives me my minus 5x. That's where this comes from. All right, this is the same thing. If you forgot this plus 1 on the end, you've got to have it, because when you distribute back in, that's how you get your plus 3 that's on the end. Okay, now we have a couple of, this says it's a shortcut, but what we're doing on this is when we're distributing, and this is foiling, so when I foil this, and I go from here to here, I end up with x squared. And then here to here is negative 4x. I go to the inside, and I have positive 4x, and then I go out here and I have negative 16. So what we see is we have x squared minus 16. Because this middle term, because one is positive and one is negative, this goes away. So here I have x squared minus 16. So when we see we have one that's negative, and one that's positive, and everything else is the same. So x and 10, one is negative, one is positive. The order doesn't matter. This one's positive, this one's negative. What happens is we know that there is no middle term. So when there's no middle term, and this only works if these two numbers are the same, and if these two numbers are the same. So I know that these are variables, but it doesn't matter. If I have x times x, it's x squared. And then I have negative 10 times 10, I would have negative 100. Now, we can see this without doing the math like I did over here. This would give me a positive 10x, and the other one would give me a negative 10x. That's why this middle term is always going to go away when we FOIL this. So if we look at this, I would have 2x times 2x. So this would give me 4x squared. and then I would have 5 times negative 5, so minus 25. Now, it doesn't matter if your variable is first or if your variable is second, like we have down here. I'm going to do it the same way. So I have 3 plus x, 3 minus x. So these two are the same, and these two are the same. The only thing that's different is one of the terms is positive and one of the terms is negative. So I'm going to multiply these two together and get 9, and I multiply these two together and I get a negative x squared. All right, go ahead and pause the video and do the last two. Okay, now what I want you to be super careful about here is we're not going to rearrange this. We're going to leave this just like that. We're not going to say x squared minus or plus 81. We're not going to do this. We want to leave it in the same order that we had. It's okay if this is a negative x squared. We don't want to move it around, okay? So now we're going to take what we just did up above and we're going to apply it to factoring. So what we did here was FOIL. Now what we're going to do is factor. And remember, factoring is the inverse, or going backwards from distributing or backwards from foiling. Up here, we factored, but we could FOIL to check our answer. Or sorry, distribute to check our answer. Here, we FOILed, and now we're going to factor. So what we see is that this is a perfect square. So if I took the square root of this, I have a perfect square. And if I take the square root of this, I have a perfect square. So if I have a perfect square, and you know, I didn't highlight that up above, but that's what we end up with every one of these. Because the numbers are the same, this is a perfect square, and this is a perfect square. I could take the square root of both of these. I could take the square root of one even with a coefficient. So the square root of 4 is 2, and the square root of x squared is just x. So every one of these ends up being a perfect square, and that's what we have here. So if this is a perfect square and this is a perfect square, then what I know is I have this pattern. So this pattern here is going to be x plus 5 and x minus 5. So let's check this. If I multiply my last two, I would have x squared, and my first two, and I multiply my last two, I would have minus 25. Now, again, the reason why I only didn't have to do FOIL to every term is because I would see I have a negative 5x and a positive 5x, so I get rid of that middle term. My pattern is the same, x plus 5, x minus 5. Same thing that I had with all of these up here. One's positive, one's negative. So if I look at this, x is a perfect square, and x squared is a perfect square, and 36 is a perfect square. So what I have here is x plus 6, x minus 6. All right, number 9 is a frequently missed question. So I'm going to circle this right here. I don't have a highlighter, but if I had a highlighter, I would highlight this. 1 is a perfect square. I can take the square root of 1, and it's always going to be 1. This is often missed, and so we end up with x plus 1 and x minus 1. Okay, one more, and then I want you to practice this. So 9 is a perfect square, and I have this x squared. Now, if this was x cubed, it wouldn't work. If it was just x, it wouldn't work. It has to be something I can take the square root of. So if I have the square root of x squared, this is the same as just x. But if I take the square root of x cubed, this is not going to be even, right? I can take the square root of this, but it's not going to be just x. So we're not going to do this. We have to look for the pattern that this is x squared. Actually, let me show you one more. If I had the square root of x to the 4th, I can take the square root of x to the 4th. Remember, the square root means we're looking for a pattern. Well, this is x squared times x squared. So I have 2 of those. So because I have 2 of those, I can pull out 1 x squared. And I know all of these are just x squared, but know that you can do this with other numbers as well. Okay? So if I take the square root here, I end up with 3x. I take the square root here, and I end up with 2. So if that one's positive, then this one's negative. And of course I can check it. 3x times 3x is 9x squared, and 2 times negative 2 is negative 4. Okay, pause the video and do the last 2. All right, here's what I ended up with. Now, what I would tell you is if you don't know all of your perfect squares, you need to know those. And I would tell you to go all the way to 20. Know all your perfect squares up to 20, but the ones that you really need to know, obviously through 12, but I would go all the way to 20. So square root of 25 is 5, so I have 5x and 5x, square root of 49 is 7. Now, what this is called when we do this, and we didn't have to go in and FOIL everything, this factoring method, we call this the shortcut here, where we just look for the pattern. So the pattern is, let me move this up a little bit. The pattern is perfect square minus perfect square. And remember that perfect square might be even a variable. So it would be numbers like 9, it would be something like x squared, it could be something like 81. All of these are perfect squares. I can take the square root of all of those and get a single number. So what this is called is the difference of squares. Now, this is important. So, difference of squares means subtraction. So, if you look at every one of our problems, I have subtraction on here. Every one of these is subtraction. And I'm going to talk about why in just a minute, but when you look for this pattern, you have to have subtraction. It's only a difference. All right, so let's look here. So this is a little bit of practice. So it says factor the following using an appropriate method. So first thing I'm going to ask myself is, can I pull out a GCF? And I can't because I don't have a number here. So over here, first question is there a GCF? Can I pull out a GCF? That's what we want to do first. The next thing I'm going to ask myself is, are these perfect squares? And if the answer is yes, then I'm going to ask myself, is it subtraction? If the answer is no, then I want to look for, well, I've already looked for a GCF. If the answer here is no, then I'm done. All right, so no GCF. Are they perfect squares? Yes and yes. Is it subtraction? Yes. If it's subtraction, then I can use my special pattern. So my special pattern is going to be x plus 12 and x minus 12. All right, so is there a GCF? Yes, I can pull out a GCF. What I see here is I have an 8 and a 10, so the biggest number that I can pull out here is going to be a 2, and I have an x squared and an x, so I can pull out 1x. So when I distribute back in, what's left? 2 times 4 is 8, and I have 1x, I need 2, so I have to add 1. And then here, 2 times what is 10? 2 times 5, 1x, I have 1x. So I'm done. Okay, I go to this next one. Can I pull out a GCF? Yes, I can. So 12 and 2, I'm going to pull out a 2, and I'm left with 6 minus x squared. Now, I know we have an x squared here, but 12 and 2 are not perfect squares. There's a difference. So remember, we want to go back and do GCF first. So I pull the GCF out, and now I'm finished. Okay, can I pull out a GCF? Yes. What's left? X plus 4. Okay, 64 and 9. Can I pull out a GCF? No, I can't. Are they perfect squares? Yes, this is a perfect square, and yes, this is a perfect square. So if I square root this one, I'm going to get 8, and if I square root this one, I'm going to get 3x. Right? So the number is 3, but x squared becomes an x. So 8 plus 3x, 8 minus 3x. Okay, so GCF, this is a little crazy because you have to recognize that this is 10 times 10, and this is 11 times 11, so there's no number that's going to come out of both of these. But this is a perfect square. So 100 and 121 are both perfect squares, and I have an x squared. So I have perfect squares. It is subtraction, so my pattern would be 10x plus 11 and 10x minus 11. Okay, so this is a great question right here. It says, does our shortcut, which is this, our pattern, does this pattern work if it's a sum of two squares, which means addition. So we're going to try this right now. So I have this x squared plus 25. So the first thing that you would ask yourself is, okay, this is x squared, so this is a perfect square, and this is a perfect square. But remember, our shortcut up here says if it's a perfect square, if it's a perfect square, I should have another one in here. So if it's a perfect square, yes, am I going to add? And if it's add, then you are done. So I have 3 here. Perfect square, yes. We're going to subtract. Perfect square, yes. But is it adding? Perfect square, no. Then we're done. So here's why we're finished. I'm going to go ahead and FOIL this. So if I FOIL this, I have x squared and then x plus 5, so plus 5x. I go to the inside, I have 5x, and I go to the last one, plus 25. Now, we know we add this, so x squared plus 10x plus 25. So now I'm going to go back and I'm going to check. Well, this is what I wanted, and this is what I got, right? So we cannot factor this as x plus 5 and x plus 5. We also can't do x plus 5 and x minus 5, because what happens is this last term, when we multiply these, we get negative 25, and this is a positive 25. So we're not able to go in here and make one positive and one negative. We know that this has our middle term cancel out, but we also can't make them both positive because then we gain a middle term. So our shortcut here of identifying the perfect squares only works if it's a difference of squares. Okay, and if we have addition, then it doesn't work. So I wrote this on the other page, but I'm going to write this here. This only works if it's a perfect square minus a perfect square. Okay, great.